So the overview, just generally of what I'm going to talk about is give a little introduction to the working group that I'm in the Center for Informatics Research and Science and Scholarship at UIUC. Then I'm going to talk about two of the case studies that we've done. One is a qualitative approach that we did in conjunction with the Data Conservancy. And the second was one that I did with a fellowship at the National Center for Atmospheric Research over the summer. Ooh, wrong way. All right, so the Data Practices Research Group really started out as a sub-award of the Data Conservancy project, which was, I guess, the way to put it is sort of the brother award from the DataNet NSF funding initiative to build out cyber infrastructures, the brother here being Data One. And so the aim for the sub-award at the University of Illinois, led by Carol Palmer, was to inform the development of curation systems and services that were specifically going to focus on long-tail science. And so long-tail science here being the idea promoted largely by Brian Hydorn. You can see on this graph to the left. This is a breakdown of NSF funding. So it was about $2.8 billion in the year 2007. 80% of the funding is typically made to awards that are sort of in the long tail of, if you think about the distribution, the long tail being about, like I said, 80% of the awards being less than $300,000. So this is really where our focus was and our ambition to sort of build out cyber infrastructures and do requirements gathering for those groups. And we've sort of had the idea to do this in the earth sciences because we had quite a few collaborators already from past projects. Oh, keep going back. All right, so by value-based indicators, these are sort of some of the assumptions that we were working with coming in. I'll start, I guess, from the bottom. So this is an idea promoted by Paul Euler of CoData that the value of data increases with their use. And this is, I think, sort of on its face, it seems intuitive, but it gets complicated the more that we think about this and look at this when we think about behaviors of scientists working in sort of small domains where there's not a lot of curation already done. And so I think, like John has brought up already, the idea of relational concepts in scale, in funding, and I think this comes into really important, this comes into play in really important ways when we think about how individual groups value research. And value here we can sort of put into this context of thinking about quality, size, scale, support, rarity. These are all things that have this relational sort of value that we don't really understand well unless we sort of go down into subdisciplines and work really closely with researchers to understand what those evidential cultures are. So that's the sort of social science approach that we're trying to take in our research group. And let's keep doing that. Sorry. And so the qualitative study that I'm going to talk about is the study that we did doing requirements gathering for the Data Conservancy. And John also mentioned, I think, a really nice perspective from, I think, that cyber infrastructure development idea is this notion of data ecologies, or there's being sort of this ecosystem of players that are involved. And we think that this is really this really bright way to sort of frame this idea of lots of different niches and habitats, but we tend to think about the small sciences having this data economies sort of perspective, where value is driving behaviors in ways that are often self-interested and cooperative at the same time. And so this is sort of getting to some behavioral economic sort of theory that we think has a lot to offer this perspective. So I'm not sure why it jumps every time I do that. So the case study that I'm going to talk about was in Earth system science, and this tends to be a science that's focused on systems dynamically interacting, such as sort of the ocean circulation and atmosphere circulation. There tends to be lots of modeling involved. And we were particularly interested in this large domain because we were familiar with a lot of the subdisciplines that do sort of observational research that feeds into the modeling perspective. So from that idea, we can think about data modelers being very sort of the consummate reusers, and we can think about the data producers being consistently making observations and depositing their data in, I hate to say well-established, but in better established repository sort of systems than we tend to think about in other domains. So what we did was we created these subdisciplinary profiles, and I'll just sort of gloss over this really quickly. But I think it's worth pointing out we had 3 subdisciplines, which were very much typically earth-based sciences: soil ecology, volcanology, and stratigraphy. And then we had sort of our reusers who were unique in a lot of perspectives and very mathematically grounded and engineering grounded, as opposed to sort of this natural science perspective. So they provided a lot of really rich qualitative data for us. So in the interest of time, I'm going to skip through the quotes, but just notice that we're pulling out value types from each of the interviews that we're doing with these subdisciplines. So the value types coming out from our reusers then, they were stressing to the utmost degree here the idea of verification. So this data is relationally helpful to me because it helps me trust or refute an existing data source that I already have, or that I already know about and can go get in really trusted repositories. The depth of description here is this adds sort of a basic fundamental understanding that's filling gaps in the data that I'm already able to find in lots of this, sort of web or network of repositories. And then this idea of equivalence, which is taken up by another research group at UIUC right now, which is this data set has the same content as another data set, but there's some sort of parameter that's different, or there's some sort of length, or there's a link to the study that allows me to use this data set in the same way. So making those equivocations was really, really important for our reusers. And this was sort of a value that they talked about over and over again. So from the producer's perspective, though, they're typifying value as sort of consistently not about how does my data contribute to stratigraphy, but how does my data contribute to an Earth system science perspective? Because they were really willing to share their data when it was the idea of Earth system science. But when it was the idea of contributing to a stratigraphy repository, they were much more skeptical. And so this sort of relation, again, comes into play largely when we're talking about sort of the values of the data. So they consistently talked about data value being of a high regenerative value. So does it have reached beyond the original intention that I gathered it for, or the original intention of its processing? And it also has a value when it's malleable. So how flexible or fragile is the data to a new application? This is something they stressed over and over again. So a lot of the values that we talk about here, I'll put a paper link at the end. It's sort of codified in that a little bit more clearly. But I'll talk about the research that I'm much more familiar with because I did most of it at the National Center for Atmospheric Research, and this is a quantitative-based study where a lot more of my expertise comes in than doing sort of the qualitative piece. So data citation initiatives are very big throughout a lot of natural sciences, but NCAR, the National Center for Atmospheric Research, has really been at the vanguard for at least the last year and a half since Matt Mirnick, who this slide is courtesy of him, took a position there. So he and Mary Marlino have been really instrumental in getting a lot of the modeling groups that are at NCAR, a lot of the software engineers, and a lot of the visiting scientists. There's an enormous amount of scientists that visit NCAR. So pulling those visitors in on a regular basis into conversations about what's the right level of granularity to assign a digital object identifier to a data set. And this is a really hard thing to sort of parse out from the climate science perspective because there's so many different granules. And so I think this is a really nice slide to demonstrate just that. So on the left-hand side here, we have a NASA data archive product, which could maybe be accessed by a scientist who then contributes it to an NCAR data archive. And that is sort of separated and pulled out by the curators there into different data sets that then get archived and assigned DOIs. But those DOIs then propagate again, right? Because a fifth data set may be generated from all those sources, combined and redeposited into another archive. So this sort of propagation of data sets continually down the line and the reassignment of DOIs becomes a really big problem that they've had to sort of struggle with and deal with. And they're still very much trying to manage and navigate that difficult space. But what's interesting is they've been doing this for about 1.5 years, and they have some citations that are starting to accumulate. So when I came to visit for the summer last summer, they were very interested in me applying some scientometric techniques to try to quantify and understand the impact and measure the impact of those citations. So this is really difficult to do, though, I think, and one of the things that we tend to be evangelists about citing data and talk about all of the really positive things that come with it, but it's going to take a really long time for enough citations to accumulate for us to be able to do reliable statistical analysis of those. And I think it's something that we're not very honest with one another when we sort of laud data citation as this perfect, great solution to a lot of concepts that we struggle with in this field. So my reaction almost immediately was that would be great in about 7 years. It's probably not good for this first 1.5 years pass. So what we did was we tried to get our hands on as much sort of relational data as possible. So we looked for bibliographic data, we looked for citation data, but we also went into a lot of the usage logs. We started to look at a lot of web analytics, and we started to look at a lot of the survey data that they had from doing past user surveys. And so the idea was to just combine and throw as much sort of data we could together to figure out what was the best framework to try to quantify and think about impact of research data sets that were granted DOI by the Research Data Archive. So the Research Data Archive is a single archive within NCAR. It hosts about 1.3 petabytes of data, both static and dynamic, so some of them are added to on a continual basis. Some of them are just archived permanently. In 2012, it served about 1 petabyte of data to 1,500 unique users from 127 different countries. So a lot of data circulating. It's a very high impact archive. But so the problem that we're trying to address largely is this idea of 2012, we had a petabyte of data served. We had 1,500 unique users. It means something relationally, again, that's impressive if we're looking at maybe digital humanities, or if we're looking at maybe a hydrology repository. It doesn't mean a whole lot in climate science because there's not a whole lot of other repositories that are comparable to the RDA. So we're looking to then try to provide generalizable metrics that we can use to relationally look at the impact of certain data sets over time. So this is sort of our ambition, what we're trying to do. And so we combined a lot of the log usage data that we had, and we started to see really interesting things like this. So this was a single data set over a 15-month period, and sort of the lightish orange that you see decreasing, the very top line is a subset request over the 15-month period. So this is users asking for a certain slice of the data over a certain time period. It's generally assumed that these users don't have programming skills that allow them to sort of computationally access it using wget or a curl script. So the lightest orange that you see that's decreasing is something that we were calling assisted users. So the idea of assisted users was they were using some sort of bulk GUI interface where they were downloading data strictly based on what they were able to navigate through NCAR's RDA website. And then we have advanced users, which sort of skyrocket, right? We have the very dark orange that you see jump way up. And these were what we called advanced users. And so these were the users that were able to, on their own, have some sort of programming script that they were able to computationally access this data. So we sort of looked at this and thought it seemed strange that it changed this dynamically over a 15-month period, because the total amount of access of the data doesn't change all that much when we add all these up at each individual point. But what we see is that this dramatic jump in assisted or in an advanced use access. So it seems strange to think that all of a sudden everyone can program, right? That's probably not the case. So what we found, though, was in one of the comment sections of the documentation that goes along with this particular data set, someone had posted a Perl script, which was really, really easy to use. And it became really widely accessed. We could tell how many people were clicking on that particular link to look at and download that Perl script, and it jumped automatically. Now, it gets a little bit more interesting because the person that developed that Perl script was a curator that worked on another data set that just sort of tweaked a few things and put it into this comment section. And so it appears as if advanced users take off, the subset requests decline, that maybe the curation isn't as robust as it was for this particular data set. And maybe the person that's particularly assigned as the data curator for this particular data set has a little bit less work to do. But it's also sort of not a fair assessment, right? Because this means that the archive suddenly became a lot more efficient. And so it has the ability to spend its time much better, much more actively. So what we're looking to try to generally do is create metrics like this that will give sort of the curation staff there an idea of what they're seeing, how they're seeing user access change over time. So what we did was we adapted this thing called the Data Usage Index. It was developed by Peter Ingebrigtsen for the biodiversity database GBIF. And we sort of came up with these whole the whole suite of indicators. So there's 14 of them. There's about 9 of them that have sort of raw metrics that can think of as sort of download rates, page views, number of times browsed, that sort of thing, that get combined in sort of novel and unique ways that give us a better look at impact. So the better, and these are the full indicators, I won't read them for the sake of time, but this is sort of the better result then that we get. So this is the same data set over the same amount of time. We see a similar trend, and take to note, so the last one we were thinking about just the number of files downloaded, so that was sort of the variation that we saw. This is what we're calling an impact score. So the variation between advanced, which is the blue, takes off, just like we saw the last one. The variation in the red, which is the assisted user, decreases, just like the last one. A slight difference in the frequency in which they diverge there. But the overall score, which we can compare, it seems like the overall score of the impact metric for the data set declines overall, right? So that's the green, that's the green score. It seems like it declines because it starts out at one point and it ends at a point that's not as high as it was. But what's really interesting here is that when we took a secondary measure of impact, which combined the browse of the page, and we took a denominator of the total number of files downloaded, we see that it actually increases much more. And so this sort of gives us a really neat perspective on the curator that was doing that work of he's actually providing an impact over that same period of time, which increases it, even though the efficiency would make it look like it decreased. So this is generally the sorts of thing we're trying to do. This is part of my dissertation work that I'll be working on over the next year and a half. And it's very sort of rudimentary right now. But keep your eye on it. I hope it develops over time. So the lessons that we learned from doing sort of this quantitative approach is that metrics are really painful, but they're also really fun. And they give us sort of a neat, painful and fun, right? Two go hand in hand usually. But they give us a neat view of sort of curation work and the idea of thinking about reuse and value in these sort of nuanced ways that we typically don't have access to through citations alone. And then sort of the suggestions underneath is start with a baseline. The Data Usage Index is a phenomenal paper. I encourage you to look at it if you're interested in sort of metric-based approaches. We have a write-up of our sort of adaptation of it at the International Digital Curation Conference this year. And then some of the recommendations we make in that paper as well is adapt for the specificities of the domain that you're trying to measure. And then find the weird patterns and explore, because that's really what science is about, right? So thank you very much. This is my email. Feel free to contact me.